Okay, today we're talking about 1.8, solving equations. It's going to be solving polynomial equations. Important things is being able to classify the polynomial correctly. Constant, linear, quadratic, cubic, quartic. You should also probably know quintic by name. That's the last one that's really named commonly. Quintic being next to the fifth polynomial. You should know terms like leading coefficient. That would be the A when it's put in standard form, which is descending order of powers, and constant term, which would be the one without an X. So as you move down, it's A in the constant, it's C in quadratic, it's E in quartic. Okay, determine whether any of the following values are roots. Well, it's to determine if something is a root has a value of 0 or it's an x-intercept. Um, to determine if it's a root, now to determine roots, you could use the rational root theorem. We won't in this class, we will just use the graphing calculator. But to determine if something is a root, usually the easiest way is to plug it in. "27 minus 2 times 9 minus 15 plus 6, 3 equals 0. Now I would need to proceed and try that with the other 3 that are there. We can see that 3 is, negative 2 is. 2.5 and 5 are not roots. Okay, that's pretty simple and straightforward. Theory of knowledge connection. When mathematicians refer to real and imaginary solutions, they are using technical terms that do not have the same meaning the words do in everyday language. What role does language play in sharing knowledge in mathematics? Does your understanding of everyday words help you understand mathematical language? So things to think about. Language is definitely important in sharing mathematics. But yes, imaginary doesn't per chance mean imaginary and real don't really mean what they actually do. Um, Complex non-real solutions to quadratics are considered in ANI HL subtopic 1.1.2. We'll be doing a lot with complex numbers in 1.1.2 and 1.1.3. Okay. Exam tip. You will be expected to solve polynomial equations using your calculator. You'll only be expected to find the real solutions unless the question asks otherwise. You do not need to know how to find all of these algebraically. You should know how to find quadratic ones algebraically. But say the one shown here, you will not need to know how to, these cubics, you don't need to know how to do algebraically, even though if there's a rational one, you did learn that in pre-calc. Okay, example 4. Find the values of x which p of x is equal to g of x. Well, we're going to do this on the graphing calculator. And so pull it out. I'm going to graph the two functions. So I'm just going to go to the Scratchpad graph because it's good enough. And I just click the button with the save above it until I get to where I need to be. And I'm going to look this up. If you don't have the entry line here, the F1 of X, the correct button to hit is Tab. Getting right above Control. And I need to look at what the functions are because I don't remember well enough. 2x squared minus 3x plus 5. I'll hit down arrow to go to the next one. Um, and you can totally do this. You could put them to set them equal and then set them equal to 0. I didn't feel like it this time. A lot of times I will just set things equal to 0 because it's easier than going and searching for where do they all intersect. Somehow I ended up on F99. It doesn't want, oh, that's annoying. Usually it'll let me scroll around. It's 3x cubed minus 4. Huh. So right now I can't see them on my graph. I guess that might have been an advantage of putting them together. I can tell it looks like they will probably intersect twice, but I'm going to need to go zoom out. So I go menu, window zoom. I'm going to do window settings because I don't think I need to go wider. I think I just need to go bigger. And I accidentally deleted the -10. I don't need lower. Let's go like 100. Okay. And I way overshot what I needed, but I didn't. I can see the intersection, so it doesn't really matter. To find the intersections, I go menu. Hint, everything is in menu on the Inspire. Analyze graph. That's going to be where I find anything that I need to find out about the graph. Window adjust windows, you can zoom there. Graph entry edit will allow you to change what type of thing you're graphing, or it'll do the same thing as the tab button. I'm going to go intersection. Lower bound needs to be on the left side. I'm going to do the left intersection first. Upper bound. There I have it. Sometimes these end up in the way of each other. You can come over here. Your hand will, you'll get a hand over the thing you can drag around. When you click on it with the center of your thing, you can drag and pull it around. So I've got one of my intersections at -1.060. They're often going to want you to do 3 significant digits, so that's -1.06. The 0 is important, has to be written to show 3 significant digits. And that one doesn't round up. We'll go ahead and now and find our other intersection, which is going to be the other side. 3.53. And if you need to, you can drag with the hand. Now, okay, let's go back and look at our next one. A diver jumps off a 10-meter high diving board into a pool. The height of the diver above the water is modeled by the equation h of t equals -1.2 t squared plus 1.4 t plus 10, where h of t is the height above the water measured in meters and t is the time after the diver jumps off the diving board. Find how much time passes after the jump before the diver enters the water in the pool. Give your answer to 2 decimal places. You can use the quadratic formula. H of t is going to be 0 when it lands in the pool. It does tell me specifically correct to 2 decimal places, so that's how I will round. I feel like solving with the calculator. So the calculator here looks kind of like a mess. So I'm going to hit the delete button 3 times. It'll ask me, are you sure you want to delete everything? And I'm going to say yes. And that will clear it out. I hit tab again. I can enter this. It is important that you use X though when graphing. Do not use T squared. It doesn't know what to do. So the T must be in the equation must become an X. And I see this. It's kind of is in the way. I could rezoom if I wanted. This is not a particularly good zoom for this, but I can find it. Where it hits the water is the x-intercept. Oops. So when I go to analyze graph, I'm going to 0. I want only highlight. I guess I pressed the wrong button. Control Z. So I just accidentally deleted my thing. Control Z is edit undo. So control and then the Z button on the keyboard, just like it is on a computer, which is wonderful. These also have control C for copy and control V for paste, which is also wonderful. Okay, this asked for it rounded to the nearest to 2 decimal places. Most things will just be 3 sig figs unless otherwise specified in DP, but this one is specified. They do check that you can do basic things like round to the correct decimal place once in a while. Okay, and we must round that up. Okay, that was 1.8.1. Now it's time for 1.8.2, which is solving linear equations, mostly linear systems, which you've done plenty in your life. You know, solving a system of equations like this. Y equals 5x plus 15, y equals 1x plus 50. We will also be doing 3-variable systems. You're not going to do 3-variable systems by hand like you did a little bit in Algebra 2 and Pre-Calc. You will simply be doing them by graphing calculator. Either you can use the system solver on the Inspire, or you can just use matrices. So here we've got 2 monthly gym memberships as given. $15 per month plus $5 per instructor-led class, $50 per month plus an additional $1 per instructor-led class. The following systems can solve these equations. So, to solve them, we'll do the first one by hand. I'm going to multiply by -5, do elimination. Actually, no, I'm just going to do -1 and let y eliminate. 0 equals 4x, so that'll distribute a negative through. 4x minus 35. So 35 equals 4x. X equals 8.75. Hence, determine which one will have, if you take 20 instructor-led classes, that would be Gym B. Which is pretty easy at this level. You will get, oh, we should also solve for y when it asks us to solve the equation. And the easiest one to use to solve for y is the bottom. So 58.75. I'm going to show you how to do matrices with the second one. And then on the graphing calculator, so I've got 2x plus 3y equals 10 and -x plus 4y equals 5. So I'm going to go to the calculator. And I have a little cheat computer next to me showing me which ones these are. Clean this up. I don't need the graph, so I'm just going to go to the other scratch pad. The matrices are in this little button next to 9. Pretty much everything on the Inspire is in the button next to 9 or the menu. So this one is just going to require a 2x2 and a 2x1. So our equations were 2x plus 3y equals 10, and negative x plus 4y equals negative 5. And I can write those out as matrices as 2. Those are a little close. 2, 3, negative 1, 4, x, y equals 10, negative 5. And to solve this, I end up going I'm doing the inverse matrix. That's my preferred way. You can do it with reduced row echelon form, like you might have done in pre-calc as well. And so I'm going to show you how to enter this on the Inspire. I'm going to start with the 2x2 matrix. 2, 3, negative 1, 4. Let me erase a little bit, make this a little easier to see. That's so now I just do for the inverse. Oops, I need to get out of the matrix before I do the inverse. I just do the power of negative 1. And that will do the inverse. It's not actually a power of negative 1. Now I need to do times and do another matrix. Well, here they have a nice 2x1. Showing you these because they're just a little faster and speed matters when you're doing a DP test. Looks like x is 5, y is 0. That's pretty nice, pretty quick. We're gonna do now a 3x3. And I'll show you that. That's slightly different as far as entering it, but ultimately the same general process. I'm going to do a different color right now. So my equations are going to be negative 2x plus y equals negative z. Nope. Minus z equals 3. That's the correct equation. X plus 4y equals negative 2. And 3x plus 2y plus 5z equals 0. Now, yes, I theoretically could do this by hand, but I don't want to. So I'm going to write it into the matrix. There's a 0 here since it's missing. And so ultimately when I want x, y, z, I do inverse of now my 3x3. Times my answer matrix. We'll go into the theory of why that works at 1.14. So on the calculator, I click this matrix one. Now I'm going to this 3x3, which allows me to set any size matrix I want. I like using the other ones for the 2x2s because they're quicker and the 2x1s, so I don't have to tell it. It's a little bit of a hassle sometimes to scroll through if you have to change them. You just kind of have to get used to the Inspire and where it lets you scroll versus sometimes the up and down arrows change the number as opposed to scrolling. Okay, so to the power of -1. There's no inverse button on the Inspire. Now, my solution matrix, I do a 3. I clicked over to let me go up and down. If I do that, notice it changes. But from this side, from the right side of it, it lets me change it. I enter 1, I get a 3x1. Oh, I forgot to put it in times. I think it'll still work. Yes, and here are my solutions. -74/35, 1/35, and 44. If you want those in decimal, you just do Control Enter. And the decimal forms do line up with what the book has. So that is how you solve a 3x3. Let's talk about the meaning of a 3x3. So I'm going to put these three things. The meaning of a 3x3 is a single point of intersection between three. These are planes. So I'm going to show you how to do 3D graphing here. On the Inspire, to do 3D graphing, you need to have you need to be in the document. So you start a new document. No, I don't feel like saving that. And I add a graph. I'm going to go Menu, Actions, I think. Nope, Menu. View. Menu View, 3D graphing. Yeah, I'm recording right now. This one's going to be a little hard to do because I don't have a Z in one of these. So I would need to solve the first one for Z to graph this. Um, and then I'll just have to do things similar to that. I'm going to choose other ones. And we get a plane there. If I hit tab again, I can enter another one. Under 1/4 x minus 2y plus 1. And right now I've got my solution would be the intersection of those two planes, which is a line. If I enter a third one, I would get a single point where this black one intersects the line of intersection. And that is the solution to my three variable system. Um, we just need to become a little bit familiarized with 3D graphing, and the Inspire is wonderful because it gives us that tool. Okay, that is the end of 1.8.